Hello, hi everyone. So welcome to the new video of this channel, and in this time we are trying to do three questions about this. Okay, and this question is again from JEE Main 2020, and in this question we are doing this geometrical isomerism thing. Okay, geometrical isomerism, and I would like to request you to pause this video for 1 minute and try to do it by yourself. Okay, and then we will solve it by doing it. Okay, so what we are doing here is that basically all these structures I'll write. So geometrical isomer of paint 2 in. Okay, first of all, if we knew the logic of this, then it will be better for you to understand. The thing is, you need a double bond, and with this double bond you can have a X group and a Y group, and in this you are having a X dash and Y dash. And the criteria for showing geometrical isomerism, criteria to show GI, is that X and Y should not be same. Again, X dash and Y dash, that should not be same. Now you can ask me, sir, what about X and X dash? I don't care if they are same or if they are not same, that is not making any difference. But with this particular carbon, this X and this Y, they should not be same. With this carbon, this X and this Y, this X dash and this Y dash, they should not be the same. So this is the criteria. Okay, now we will do all the structures one by one. So 2 methyl pent 2 in, and again you have to do the bond dash formula. Okay, pent 2 in means 1 2 3 4 5, 2 and 2 methyl, like that. Okay, then 4 methyl pent 2 in, how it is looking like? 1 2 3 4 5, 2 methyl, and you are having fourth position, you are having a methyl group, right? Then 4 methyl pent 1 in, so 4 methyl pent 1 in, 1 2 3 4 5, you are having a double bond here, and at 4 position you are having a methyl. I already got my answer, and 4 methyl, 2 methyl pent 1 in, so 2 methyl pent 1 in means 1 in, and at 2 position you are having this. Okay, now what is the criteria? For any carbon, this X and this Y, and for this carbon, this X dash and this Y dash, X cannot be equal to Y and X dash cannot be equal to Y dash. Okay, if this is the criteria they satisfy, then they can form geometrical isomerism. Okay, let's see what is happening here. So for this carbon, if I see, you are having a methyl group here and you are having a methyl group here. Now both are same group, that is not your answer. Okay, now you come here, you have CH and H. And why? Because carbon is having tetravalency, so you have to satisfy the tetravalency, you have to add the hydrogen. Both are same, it is not your answer. You come here, this is also carbon is having 2 hydrogen, both are same, this is not your answer, so definitely this will be your answer. But let's check, this carbon is having a methyl group, obviously there is a hydrogen, so they are not same. This carbon, you are having this group and this hydrogen, and they are not same, that means this will be your answer. So that means option number B, option number B will be your answer. You see, such a easy question, but you have to know this criteria. Okay, and by this you can do any question. Obviously what you have to remember, for any double bonded carbon, these two groups should not be same. For any double bonded carbon, these two groups should not be same. Okay, so very quickly I am giving you a question to do. You have to tell me this molecule, it will show geometrical isomerism or not. You have to tell me in the comment section, you can tell me this molecule if they can show geometrical isomerism or not. Okay, and if possible you can do the IUPAC of this molecule also. You can do the IUPAC of this also. Okay, so this is kind of a homework for you. Okay, now go to the next question. Next question, it is given, what is the major product from by HI on reaction with this molecule. Again, this reaction, if you do for this, you need a proper knowledge about reaction mechanism. Proper knowledge about reaction mechanism is needed, and no need to worry, it's very easy. Okay, we'll do one by one. So for this carbon, these three groups are there, and then it is CH double bond CH2. Okay, it is given HI. So if you react this with HI, obviously your double bond is electron rich, so it will give electron and to take this hydrogen, and this I will leave. And the first step is the formation of carbocation. So I am making the carbocation. Let me change the color. So CH, and you are having CH3, and bond is breaking in this direction. That means on the opposite direction this carbon is positive charge. Now previous day also we have solved this type of question, and like these questions are JEE Mains favorite questions. Okay, every time this kind of question you can get. So this carbocation, the carbon having positive charge is directly, the carbon having positive charge is directly bonded to one carbon and two carbon. So it's 2 degree. 2 degree means it's moderately stable. It is moderately stable. But whenever there is a carbocation formation, you have to go, you have to check if higher degree you can make it or not. Because carbocation stability order again 3 degree greater than 2 degree greater than 1 degree. This is very important. Carbocation stability order is 3 degree greater than 2 degree greater than 1 degree. So you can say that, sir, these are methyl groups, right? Yes. And if I shift one methyl groups like this, okay, let me do it again. So sir, if I shift one methyl group like this, yes, you have to do methyl 1 to shift. And what is the step you are doing? You are rearranging the carbocation. Carbocation rearrangement you are doing. Carbocation rearrangement. Okay, so if you do this, then I am writing this carbon now. Carbon having a methyl group. This methyl group I have written, and this methyl group I am writing right now. But this methyl group is actually not with this carbon right now. This has gone to this carbon. Methyl already having a methyl, already having a hydrogen, and bond is breaking in this direction. That means you will get a positive charge here. Let me change the slide. So ultimately you got these things: CH3, CH3, CH, CH3, CH3, and this carbon is having a positive charge. Now the thing is, sir, what is the benefit of doing this step? The benefit is the carbon having positive charge is now directly bonded to this carbon, and this carbon. So this is 3 degree carbocation, and 3 degree carbocation is the most stable form. So to gain the stability, you have done this step. Okay, now you know what is the thing given. You see HI on reaction, so I minus is still there in the reaction medium, so I minus will come, and that will stabilize the carbocation and form a bond. So this is the thing you will get. CH3, CH3, this you are getting. Now if you don't do the rearrangement thing, now you will not get the marks. -4 you will get. But you have to have this knowledge about rearrangement. Carbocation rearrangement is examiner's favorite topic. Okay, every now and then you will get this answer. Okay, so what is your answer? You will get as option number A. Option number A is your answer. But if you don't know this, probably you will mark option number C. But that is not correct. Your answer will be option number A. Okay, so 2 questions I have done, and now we'll go for the third question. And for the third question, you see again this is a rearrangement of carbocation kind of thing. We'll start. Okay, so it is CH3, 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 CH, OH. This is even easier, like it is exactly like the previous thing, and you see it is coming in 2021. So like we are only 2024 right now, so in the near past this type of questions are coming. Okay, so concentrated H2SO4 means it is H plus you can get, right? So oxygen lone pair will easily take this H plus and initiate the reaction. Okay, they can ask you that what is the name of this step. This step is, the name of this is protonation of alcohol, right? Protonation of alcohol. Why it is protonation of alcohol? Because the alcohol is taking a H plus. H plus means it's a proton. Okay, let me go to the next slide so it will be easier. So CH3, C, CH3, CH3, CH. Now this OH is taking a hydrogen, it will be OH2. Oxygen having 3 bond, that means oxygen is having plus charge. Now this thing. Now the benefit of this reaction is this, now it is becoming a very good leaving group. It's a very good leaving group because if it leaves, it is leaving as a neutral water molecule. It will leave and you are starting your E1 mechanism. You are starting your E1 mechanism. Sir, E1 means, sir, E1 means elimination unimolecular. We will do all these reactions, okay? When I will teach you like topic wise, you can understand. Now, sir, again I am making a 2-degree carbocation. Yes, you know, now you are expert of this 2-degree carbocation. Why? Because the carbon having positive charge is directly bonded to 2 carbonate. This is a 2-degree carbocation. If you don't get anything, you please let me know in the comment box, okay? The carbon having positive charge is directly bonded to this carbon and directly bonded to this carbon. So it is a 2-degree. So 2-degree means we have to try to go for 3-degree, right? Yes, we have to go. How can we do this? We can do methyl 1,2 shift. Methyl 1,2 shift. So that step is rearrangement of carbocation. So if I do this, sir, I will get this thing. And this CH3 group is now with this carbon. Yes, CH already having a CH3, now having a CH3. And this carbon is having a positive charge. Now, you see in this question, concentrated H2SO4 is given, concentrated H2SO4 is given, and all the products are alkene. That means you have to do elimination in the last stage. Okay, sir, elimination I have to do. That means I can take this H, right? This H, yeah. Take this H minus H plus. So you are getting this molecule as your major product. Sir, why this is major product? Because this is the most stable alkene possible. Sir, how it's the most stable alkene possible? Okay, let me just take a slide for this. Yeah. So what I will do, I will take this molecule. Okay, this molecule I will take in the next slide. Okay. So if I take this molecule in the next slide, and if I write this like this way, you can argue with me that, sir, I can take the H from here as you have done, and we will get this product CH3C, CH3, double bond C, CH3, CH3. Or I can, there is an alternative way, we can say alternative way, that, sir, I can take this H plus also. Yes, you can. So do this. Definitely this is a possibility. Okay. So if this is the thing, now we have to calculate the stability of alkene, and stability of alkene means we have to calculate hyperconjugation. So we have to know this thing. Okay. Stability proportional to hyperconjugation, proportional to number of alpha hydrogen atom. Okay, now we calculate alpha hydrogen. Sir, how to calculate alpha hydrogen? I don't know how to calculate. It's very easy. This carbon and this carbon is your double bonded carbon. Now the carbon that is directly bonded to your double bonded carbon is called alpha carbon. So this carbon is directly bonded to your double bonded carbon. This is your alpha carbon. So sir, this is also alpha carbon. Yes, this carbon is also directly bonded. This carbon is also directly bonded, and this carbon is also directly bonded to a double bond, so alpha carbon. And the hydrogen attached to alpha carbon is called alpha hydrogen. So how many hydrogen? 3, 3, 3, 3. 12 alpha hydrogen you are getting here. Now you see here, this carbon and this carbon is your double bonded carbon, and the carbon that is directly bonded to a double bonded carbon is called alpha carbon. So which is your alpha carbon? This one is your alpha carbon. Why? Because this carbon is directly bonded to your double bond. This is alpha. Any other alpha? Yes, sir. This carbon is also directly bonded to the double bonded carbon. This is also alpha carbon. Yes. How many hydrogen? Here 3 and here 1. So total 4 alpha hydrogen. Which is stable? Sir, this one is stable. Which one is major product? Sir, this one is major product. That's why in the previous slide I have done this as my major product, and that will be my answer. And you see, this type of things are very easy. You have to know this and you have to do this very quickly. Okay, option number B will be your answer. Option number B will be your answer. So this type of questions regularly comes in the exam, and you have to do this. And not only this, you have to do this very quickly also. Okay, these are easy questions. So I hope you understand this, and if you have any further problem, you please let me know. Okay, and I have given you a HW, you can do this, and if you ask me to do any special question, you can ask me. Okay, you know how to contact me. Okay, so I hope you understand this, and okay, we'll get back again. Thank you.